open the building which we run the analysis for the tall building. This is the model we created already. Then go to the tables, analysis and result. Then frame result, click on the column forces. Then arrange in a story one. Okay, here we want only dead load cases. Then sort ascending. Okay, these are all the column C1 to C16. Okay, and then we have to know the column numbers here. To display the column number, go to the view option and set view options and click on labels and click on apply. Okay, here we see all the column numbers like C1, C2, C3, C4, C5 up to the C16. And now go to the structural object and story one. Here click C1. Here you get column sizes. Click on all the columns. Here you get all the details of the column sizes. Here two column sizes are there, 500 by 500 and 600 by 600. Okay, now define section properties. Go to section property and select materials for the 500 by 500, that is M40 and HYSD 500, similar for both. Okay, now this is a problem statement we got from our design problem. Okay, this is a problem statement. It is a footing size which is 18 by 18 and 2-meter extension from the either side. This is how we have to find the subgrade modulus, and this is for the calculation for the design strip. Now go to the save software and set a IS456. Then add the cover and rebar options. Then set the grids. That is 18 meter we have. So grid line will be the 19 numbers in a both direction. Okay, now set a 1 meter. Okay, this is how we got a grid. Then go to the material, define material M40 concrete and add all the standard values for the M40. Click on OK. Then add a HYSD 500 bar and add its standard properties. Okay. Then go to the slab property, add the slab property, that is for the mat footing, which is M40. Add the thickness 500 mm. Click on OK. Then you define the column property, add a new column, column 1. We have two columns, 500 by 500, first one. Add its sizes 500 by 500, click on OK. Then another column 600 by 600 and click on OK. Now add the soil property, soil. We have 3 into 10 power 4. Okay. Load cases, check load. Then add the load combination for the ultimate load and also for the. Okay, now add for the service. Okay, click all the service option and click on OK. Two load combination are added successfully. This is how we have to draw the slab. Okay, the slab has been drawn. Then go to edit. We have extension of 2 meter on either side for the all. We got offset. Okay. Now draw the columns of 500 by 500 mm, having a 6 meter apart. Okay, locate all the columns of 500 by 500 mm at initial stage. Okay, then add a 600 by 600 columns at the center. Okay, then add column strips, which is having a 4 meters width. Draw all the strips in a layer A. Then in a layer B. add the strips, 4 strips in y direction. Okay, done. Now click on the footing area and add the soil property, that is soil 1. Then add a load on a column, that is for a dead load, 500 by 500 column. Then again add a live load, which is having a 797.6. Then in similar way, add all the load for the 500 by 500 columns. Here the 500 by 500 columns are C1, C2, C3, C4, C5, C8, C9, C12, C13, 14, 15 and 16. Okay, done. Now we added all the load for 500 by 500 column. Then add a load on the central portions, that is for the 600 by 600 columns. Add a dead load and live load in a similar fashion as we done for the 500 by 500 columns. Okay, now we successfully added all the points load. Okay, then we have to assign the rebar properties. Then click on a okay, we are checking. Okay, done. Okay, now select our footing and add a rebar options and add a HY as defined. Then click on a strips and add all the rebar properties. Click on all the strips of layer A and layer B. Okay, done. Now run the analysis. Now run analysis and design. Okay, now click on the punching shear options. Okay, we are the shear option getting higher, then we revise once again the thickness going to the material property, then again we are getting a punching shear higher, then we added a thickness to 1200, then again run the analysis. Now we got a shear value, punching shear value less than 1. Okay, now view the option in 3D view, extruded option. Okay, this is the plan view again. Okay, now next part is to detail to view the different load combinations. Okay, before that, okay, strict forces and all in a layer and layer A and B. Okay, now get a impose reinforcement. Okay, now similar in the layer B for load combination A. Okay, this is a crack width values for the top, slab top and slab bottom. These are the minor cracks and start detailing option. This is a detailing framing plan. Go to the framing plan. This is framing rebar table, bill of quantity, having all the length of the rebars with bar size. This is a slab plans like rebar plan, top plans, rebar plans, all for all bars. This is section at 1. And this is section reinforcement profile for the layer A. Thank you guys for watching.